Okay, we are back with problem number 2 in our list of 20 problems. So here we have our function. Let's get this number 2, f of x equals 2x cubed plus 3x squared minus 36x minus 27. This kind of a polynomial is pretty easy to find the derivative of. So we just take each term. The 3 comes down times the 2, makes that a 6, and the power goes down 1, so that power becomes a 2. The 2 times 3 makes a 6. The power goes down to first power, which we don't have to write. The derivative of the linear term is just the coefficient, and the derivative of the constant is 0. So there is the derivative. To find the second derivative, we just find the derivative of the first derivative. So use the same rule again. 2 times 6 is 12. Power goes down to 1. And the derivative of that is 6. And of course the third derivative would just be 12, and the fourth and fifth and sixth and all higher derivatives would just be 0. So when you're doing a polynomial, it goes down a degree each time you take a derivative. So in a sense it keeps getting a little simpler to go to find the derivative as we go. Now we also want to find the tangent line at x is 1. So we need to go back to the original function and plug in 1 for the x. Oops. Okay, 1 cubed is 1, so that times 2 is just 2. 1 squared is 1, times 3 is 3, 1 times 36 is 36, so we're at that point. Let's see, 2 plus 3 is 5, and negative 36 and negative 27 is negative 63, and that's going to give me, excuse me, negative 58. So that tells us 158 is a point on the graph. In fact, it's on the original graph, and it's on the tangent line too. It's on both. It is the point of tangency. Now, we also need to find the slope of the tangent line at that point, which is f prime evaluated at 1. So again, we take 1 and replace all the x's by 1. And again, 1 squared is 1, so basically these are like this. Let's see, I bet we can do this in our head. 6 plus 6 is 12, minus 36 is negative 24. So that's going to be the slope of the line. And then the line then becomes, I'm going to call it t of x. So it's y equals t of x equals m, which is this slope here, times parentheses x minus the x-coordinate, which is 1 of the point of tangency, plus the y-coordinate, which is f of 1, like that. And so I'm going to leave it like that. Okay, so you might write these down. There's f of x, 2x cubed plus 3x squared minus 36 minus 27. F prime of x is 6x squared plus 6x minus 36. F double prime is 12x plus 6. And the tangent line is negative 24 parentheses x minus 1 minus 58 equals t. Okay, so let's take that and graph it. So I'm going to pull up a graphing utility on the calculator here, on the computer here. You can do this on your graphing calculator. Y equals, let's see, the original function. Let me get where I can see where I've written these down. Okay, so y equals 2x cubed plus 3x squared minus 36x minus 27. And we'll adjust the window here in a minute for that. The derivative is 6x squared plus 6x minus 36. And the second derivative is 12x plus 6. And the tangent line is y equals negative 24 x minus 1 minus 58. Alright, that's a lot of stuff here. Let's see here. Looks like we maybe could come in a little bit on the sides and need to expand up in the top and bottom. So let's go to the grid range. Let's just go negative 10 to 10 to start with. And let's go, how about negative 30 to 30 and see what happens here. Maybe we need to expand out some more vertically. So finding the right grid range is a little bit of trial and error. How about negative 50 to 50? Let's see what happens there. Closer. Oh, let's go all the way out to 100. Maybe too far. How about negative 100 to 100? Oh, that's not bad. That looks pretty good. Let me do a couple of things here. So I want to take this and place that on the f of x, which is this guy right here. And I want to take the label for f prime and place it on the derivative, which is this little something right here. And then I want to place the label for the second derivative is okay, it's this orange line. No, that's the tangent line. It's this darker line here. And then the tangent line, we'll just label it here. Let me change some colors here. We'll just kind of try to stay with the same colors. The original function is blue. We'll make the derivative red. And then we'll make the second derivative purple. And then the tangent line orange is fine for that. Alright, does it look right? Let's see. If the original function is here, okay, the derivative looks like it goes through negative 3 and 2 on the axis. That's when we're going to have a minimum here when x is 2 and a maximum here when x is negative 3 on the original function, because it has a horizontal tangent line. That's a potential extremum there, so you have a max or min happens when the derivative is 0. The derivative is at a minimum where the second derivative is 0. Right here it looks like at a negative 1/2. And that's also going to be the same place right there where the original function has an inflection point. So notice it changes from concave down to concave up. So the inflection point happens when the second derivative is 0 and the first derivative is at a maximum or a minimum. Okay. The maximum or minimum of the original function happens when the first derivative here, the purple one, the red one, is 0. Alright, let's notice some more things. The blue function is increasing over here up to negative 3. So that says the derivative is positive there, which it is. And then the original function is decreasing from x going from negative 3 to 2. So that means between there, that's where this first derivative is negative. Makes sense. For x is bigger than 2, the original function is increasing and the derivative is positive. Makes sense. The original function is concave down from negative infinity up to negative 1/2 right here. And so that means that the second derivative is negative. The purple one here is below the axis up until that point. After that, the second derivative is positive, meaning the derivative is increasing and the original function is concave up. We do seem to have a point correctly graphed here when x is 1 and y is negative 58. Okay, right here, and that is a point of tangency for our tangent line. So everything looks like it's looking good there. So let's I'm going to copy that. I'm going to There's my computations, and I'm going to paste the graph there. Okay, and we'll do the next problem in the next video. If you want to preview it, there's number 3. You can see the formula that we're going to be looking at in our following video. So if you haven't done it yet, go ahead and try number 3 before you click on the next video.